Hello, welcome. My name is Alexander Diamond. I'm leading the data analytics team at IOHK, and I would like to show you how we tackle the data on-chain in Cardano. So data analytics is about the on-chain data. We combine this with other data from other sources like Google Analytics and so on. And we recently moved from just the static data, from on-chain data, to real-time processing of event streams. I'll show you through this. So since the inception of Cardano 4 years ago, we have seen a dramatic increase in its usage and the size that are transacted. So we see more than about 500 or 400,000 transactions per epoch. And even more profound, the number of bytes that these transactions carry, we have seen a spike to 300 megabytes per epoch. That's quite a large number. You don't need to know the exact numbers, but it's just interesting to see how this is growing fast. The green dots indicating those graphs, the hard forks from Shelley to Allegro and Mary. And the same is true for metadata, which was introduced in Allegro. Also, people have been picking up that feature and are using that actively. So we see quite a load of metadata being added to the outputs of transactions. And we assume that after Alonzo hard fork, there will be even more metadata being used. And the same for multi-assets, like where more than 99% of the tokens minted on Cardano are actually NFTs. As far as we see, they have been picked up starting 1st of March this year. And also for the Alonzo hard fork, we will see an increase in these usage of multi-assets and native tokens on-chain. The transactions can be broken down into the features, the type that they're actually using. So if we look at the total transactions, they're increasing for the last dozen epochs now. And if we look at the fraction of the different types, like for example, that we see about 10% transactions being about delegations, a little bit below 10% are carrying metadata, and a bit more than 10% are actually minting native tokens. So, but still metadata and minting can go into one transaction. But this indicates a bit that the usage of these features is quite important on chain. Now moving more into the dynamic field of real-time processing, let's assume we have three pools here, and we watch them operating. A user interacting with a smart contract will generate transactions. They will be validated and included into blocks by the pool operators and sent to the network again. We will observe that transaction data and put on the interface towards our customers. So we aim at interfacing with customers through defined interfaces. We can also optionally put on some buffering to, for example, reach a certain confirmation depth in blocks, and then hand over this data in real time, or as I said, buffering, to the backend systems of our clients for further processing. We have also been working a lot into accessibility of these data and visualization in dashboards, for example, or accessibility through APIs, and we develop tools for doing analytics on mainnet testnets, and we can also do it on permission networks. So we have been building this native tokens analysis dashboard that is about the analysis on what's available and what kind of tokens are minted on Cardano. We're building this a smart contract usage dashboard that will track how, after the Alonso hard fork, smart contracts are being used on Cardano. And we've also investigated into stake pools, rewards, and portfolio reconstruction, and so on in another dashboard. As APIs, we provide REST APIs for the ledger information, but also marketing information. And we've developed a number of tools that help us doing these analyses inside. For example, the chain follower that listens to the chain and events and new blocks with transactions on chain and puts that in real time to, for example, a message bus like Kafka Streams. An application that can make use of this is Alert, that is monitoring in real time such events on the bus and can generate new events. We've also built a distributed UTXO querying, where we took the chain data and made it a knowledge base. And using Prolog queries, we can, in a highly parallel fashion, we can fast and efficient query that data structure. Let me also introduce to you the team. We are fully remote. We are dedicated to delivering high-quality solutions, and we're eager to learn new technologies like Bluetooth and smart contracts and in continued training. So we have Thomas, our senior data engineer and cloud engineer from Greece. Tenze in Addis Abeba, a software engineer. She's about to leave the team and continue her studies. Meron, also in Addis, is doing data engineering and programming dashboards and modeling data. Also data engineer, Yenat in Addis Abeba. She also has a nice background in machine learning that we make use of. And me, I'm joining from Europe, Switzerland, and yeah. And if you're interested, we still have open positions. One in Addis Abeba about the data engineer and cloud engineer. If you're interested, please join and ask for these. Yeah. So to sum up, we aim at the integration of on-chain data and analytics with this real-time event processing that we want to stream into our customers' back-end systems for further integration. That's a helpful integration and valuable if you intend to run smart contracts on Cardano, then this is the way to go to get those events and react to your clients' interactions. Thank you very much for your time, and if you have further questions, feedback or questions, please write to this enterprise.services@iohk.io email. Thank you very much for your time.